Have you ever wondered how an app can feel lightning fast, whether you're using it in Tokyo or Toronto? Well, that magic is buried deep in the system's architecture. But there's this hidden challenge that every single global app has to face. What do you do when users are writing data from all over the world, maybe even at the exact same time? So how do they solve this puzzle? Let's dive in and break down the patterns they use.
All right, so here's our game plan. First, we're going to really unpack what this global write problem is all about. Then we'll look at a few classic solutions, the one ruler method, also known as leader-follower. After that, we'll check out the council vote idea of leaderless systems, and then a really cool one called eventual harmony with CRDT-like patterns. Then we got to talk about the modern easy button, manage databases, before we wrap it all up with how an architect actually makes the final call.
So let's jump right into the core challenge. When you're building for a worldwide audience, you are in this constant tug of war. You're fighting between two absolutely critical goals: making sure your app feels incredibly fast and making sure your data is always correct.
Okay, let's make this super real. Imagine you're building something like Google Docs. You've got a user in London and another user in New York, and they are both editing the exact same sentence at the same time. What happens? Who wins? Does one person's change just get erased? This is the exact kind of scenario that keeps architects up at.
Now, a really key concept we have to get our heads around is write latency. And look, this is way more than just your internet speed. Think of it as the total time gap from the moment you click save until the system can finally send back the all-clear signal confirming your data is tucked away safely. For global apps, that delay can be surprisingly long. And this right here is the fundamental trade-off. There is no magic wand you can wave to fix this. You can either try to fight the literal speed of light, the time it takes data to zip across oceans through fiber optic cables, or you can accept the risk that sometimes data from different users is going to clash. You really do have to choose your poison. Okay, so how do we actually solve this? Let's start with the first and probably the most traditional approach, the leader-follower pattern. I like to call this one the one ruler model. So what's happening here? Our user in London makes an edit. Now, that data can't just be saved locally in Europe. Oh no. As you see in step 2, it has to take a long trip all the way to a single leader database. Let's say it's sitting in North America. It's only when that leader gives the thumbs up in step 3 that a success message can finally be sent back. And then finally, that change gets copied or replicated to all the other follower databases, including the one right back in Europe. What a journey. Now, the huge plus side here is something called strong consistency. There's one single source of truth, so you never get those messy, conflicting writes. It's simple, and everyone sees the exact same data history. But the downside, oh, it's a killer: high latency. Our poor user in London is stuck waiting for their data to make a round trip across the Atlantic and back, and that just feels slow. Okay, so if the one ruler model is just too slow, what's the alternative? Well, let's move on to the leaderless pattern, which I think of as a council vote. This approach completely flips the script. Here, when our London user writes some data, it gets sent to a bunch of nearby servers all at once. The system doesn't wait for a single boss. Instead, it just waits for what's called a quorum, which is basically a majority vote from these local servers. Once that majority says, yep, got it, the write is a success and the user gets a super fast response. The benefit here is obvious, and it's huge: low latency. Writes feel instant because they're happening right near you. Plus, it's highly available. If one server goes down, the others can still get that majority vote. But, and this is a really big but, what happens if our New York user writes to the exact same piece of data at the exact same time? Uh-oh. Now we have a write conflict. The system has to somehow figure out how to resolve two different versions of the truth, and that's where the complexity just skyrockets. You know, this whole problem of write conflicts brings us to a really fascinating and much more advanced idea: CRD-like patterns. The goal here is something you might call eventual harmony. Okay, CRDT stands for conflict-free replicated data type. I know it sounds super complicated, but the core idea behind it is just brilliant. Instead of trying to prevent conflicts from ever happening, you actually design your data so that conflicts are mathematically impossible. It's wild. These data structures are built from the ground up to just merge changes from anywhere automatically without ever losing information. The power here is pretty clear. No more write conflicts. It's perfect for collaboration. But here's the massive catch. It only works for very specific kinds of data. Think about adding items to a shared shopping cart or hitting a like button a bunch of times. You can't just apply this magic to any old database field. It takes a ton of specialized work right in your application code. So we've looked at 3 patterns, and each one has some seriously complex trade-offs. It's a lot to think about, right? And that brings us to the modern approach. What if you could just press the easy button? And that is exactly the promise of managed global databases from all the big cloud providers. The philosophy is just so simple. Let the cloud provider handle the complexity. I mean, they've already hired armies of brilliant engineers to solve these exact painful problems for you. The pro here is just immense. You can get your product to market way faster. Your team doesn't have to stress about the nitty-gritty details, and you get a super sophisticated system right out of the box. But as always, there's a con. You do give up some control over how things work under the hood. It can definitely be more expensive, and you might get locked into one specific company's ecosystem. It's that classic trade-off between engineering simplicity and long-term control. All right, we have covered a lot of ground. So how does an architect actually make a choice? Let's bring it all together and look at the final decision-making framework. This table really sums it all up. Look, if you need absolute ironclad strong consistency, like you would for banking, you're probably going to accept the high latency of a leader-follower model. If uptime and fast writes are everything, you'd look at a leaderless system, but you'd have to plan on how to handle those conflicts. For something collaborative, like a shared document, the high complexity of a CRDT-like pattern might actually be worth the effort. And of course, if you just need to move fast and you don't have a team of distributed systems experts on hand, a managed global database is often the most practical choice you can make. So here's the thing. There is no single best answer. It always comes back to trade-offs. And that brings us right back to the fundamental choice, the one question every architect has to answer for their next global feature. Which one are you willing to compromise on? Is it speed? Is it correctness? Or is it simplicity? The answer to that question is what will guide your entire architecture.